Hi everybody, Scott Stanchfield here. Let's talk about Android services and broadcast receivers. To put this in context, there's 4 application components that the system can talk to. We've already seen an activity which the Android system will create an instance of and then talk to using lifecycle functions. Next, there's services, which allow you to do long-running tasks in the background that you can communicate with or expose an API for other applications to talk to. Broadcast receivers allow you to receive system events as well as events from other applications or even your own application. And content providers allow you to expose data that your application manages to other applications. You generally won't be creating a lot of content providers yourself. These are usually if you have some kind of a major data store that you want to expose. For example, the Android system provides a contacts content provider, and that will allow you to share your contacts across multiple applications so that they can display them, edit them, and so on. The communication mechanism between the activity and the service and the broadcast receivers is generally using an intent, which is an object that describes what the user wants to do, not necessarily where they want to do it or how they want to do it. So if the user said they wanted to edit a document, that might bring up an application for editing that kind of document. Or if they wanted to view a web page, it could go out and any applications that have registered to view a web page can display it. In other words, browsers. An intent is used to create activities, we've already seen that, and jump over to them. But you can also start up services using an intent. Broadcast receivers can receive intents that were sent across from any application or service or activity, and it will not be limited to just a single application handling it. Any broadcast receiver that's available for it will handle that. There are a few little restrictions on that where in later versions of Android, they won't let you capture just any random event coming in if you define the broadcast receiver in your manifest. But if you define it programmatically, you can catch pretty much anything. We've seen a couple ways to do work in the background where we could use a coroutine to take the work off the user interface thread. That way the user interface thread doesn't get hitchy. We can go off and fetch data from a file or a network or whatever. You could do the same kind of thing using threads. There also was this thing called an async task. And the reason I'm bringing this up is because there's still some pages up that talk about this, and it may seem like this is a good thing to do. Async tasks allows you to define an object that has a unit of work to do in the background, as well as a unit to do before and after in the foreground. So you could do some setup, like setting up a progress bar, run your background work, and then update the UI at the end. Now the problem with this is that the async task was typically defined inside of an activity. And what that means is that it has an implicit pointer to the actual activity code, which is a real big problem if you have a configuration change. If you rotate the device, for example, it's going to destroy the old activity and recreate it. The problem is that that async task doesn't get destroyed along with it. It keeps running and still has a pointer to the old activity object. So if he tries to do anything calling functions in the activity when the activity is in a destroyed state, worst case, the thing's going to blow up your application. Best case, it may just get ignored. Like if you try to update a view on the screen, perhaps it just won't do anything. But in many cases, it would crash. Do not use async tasks. If you ever see an article talking about them, it's probably several years old. This has been deprecated many, many years ago. Now, if you want to do some background work that can keep running even if there's no activity up in the user's face, you can use a service. And what the service will do is he runs as an independent component whether or not an activity is running in the foreground and can perform whatever task you'd like back there. It also has the advantage where it can front an API for other applications to use. So they can ask your application to do things or get data through a controlled API that you define. Now later on, we'll also talk about workers, which are more of a fire and forget. For example, if you want to download a file in a browser, it could kick off a worker, which will try downloading the file. If for some reason it fails, it could try again, or it could even wait until later when there's a network connection available or when you're plugged in to actually do that download. So the workers are more of a, at some point in the future, something will run. With services, we're talking about stuff that we want to run right now. So the main things that a service can do for you is it can share some kind of processing. So if you have an algorithm or a function that another application wants to use, you can call your service to do that. You can also share data via an API. So if you're managing some data, whether you've got that data internal or whether you've gotten it from a resource or a sensor or somewhere external, you can share that with another application. It's also used to keep something running in the background. In our example, we're going to show you how you can keep music running in the background when the user gets out of the activity. You could also use this as a polling mechanism, although I really don't recommend you do polling. There's other mechanisms you can use to do what they call cloud messaging, where you can register and something can push a notification to you. But if you do need polling, you can set up a service to do that for you. A better way, though, would be a worker for something that you want to once in a while check to see if something's happening. There are two types of services, and you could combine them if you'd like to, making a hybrid. The started service is one where you fire off an intent to say, start the service, it goes and it starts doing something. You can set it as a foreground service, and that's actually pretty nice because it will tell Android that this should be something that they should try their best not to kill. In general, Android will do its best to not kill the activity that's in front of the user's face, and then any foreground services after that. Anything that's not a foreground service, the system can kill anytime it needs more resources. If you have a bound service, this is something where an activity, for example, will connect to that service so it can communicate via an API. And that service will keep running until there's no binders left. So if you have an activity that connects to it and binds to it, and then we move to a different activity, there actually is a little bit of an overlap between the two where the second one connects before the first one disconnects. And as long as one person was connected to it, you're still using that same service that was bound. A hybrid service basically does kind of both of these things. You can start it up, and then at some point you may want to bind to it just to do a communication. If you're defining and using a service inside of the same application, keep in mind it's running in the same process, the same memory space. That can allow you a very simple binding to it, and this is useful if you want to keep things running if the user closes the activity. That's the main reason for it. In general, if you just want to run a little something in the background while an activity is running, you're better off using a coroutine or a thread. If, however, the service is in a different application, then you're running in two completely separate processes, the client for the service and the service itself. The service will expose whatever data and function via the API that's defined, and we'll see how to do that just to do some simple reporting. I'm going to go through a few diagrams to kind of show you how these things might look and how the communication might work. If we're talking about a bound service in the same process, so we have a process here, we have an activity and a service. We bind to the service, which gives us an API. That API is represented by an interface. In this particular example, that interface has a function X. The activity can just call function X like anything else. If it's in the same process, it's really communicating directly to that service. If we want to do a callback, we can have in that interface an add callback of some sort function, maybe an add listener, add reporter, something like that. And we pass the object that we want to the service. The service will then do whatever work it's going to do, and whenever it needs to talk to the callback, it just calls that callback directly. We can also call it other functions as well. Before we talk about talking to other processes, so when you have a service in a different application, we need to talk about how data gets sent back and forth between the two. In general, if the data is a primitive type, that's easy. It's just binary primitive data going back and forth. However, if it's an object that you've defined, some kind of custom class, we need to take that object and marshal it. Marshalling is the act of taking an object and converting it into just a binary stream that gets sent between two processes. In Java, if you were using remote method invocation, which is kind of similar to something we're going to do here, you would use a serializable class. And that creates a binary stream of all the information of the class, plus some information that keeps track of what version the class was, as well as the names and types of all the properties. This makes it so the serialized object can be stored in a file if you'd really like to, or it can be sent across the network. And there's checks there to see, is the file I'm reading the same version as the data object that I have in memory? In Android, you generally don't use serializable. Most of the time, we're just concerned about point-to-point communication between two processes. So what we really want to do is have a very efficient way of sending data across. And that's where Parcelable comes in. If you use the Parcelable interface, you're saying that your class can just write his data in the same order as he's reading it on the other end. And that makes it so it's much more efficient. You don't have all the extra identifying information. But because of that, you really can't write it out to a file. Because if you write it and then later on try to open it with a later version of the class, it likely won't work. So keep in mind, this is really strictly for in-memory current process use. To make a class parseable, you really need two things, a way to write it out and a way to read it in. We're going to take this data class that we've defined here that has a name and an age, and that name should really be a val. I'm not sure why it's not a val there. And in order to make it parcelable, we just have it implement parcelable. So inside of here, there's two parts to really implementing parcelable. First is this write to parcel function. And he's just saying, write out our fields in a specific order to this parcel object. Describe contents is just used internally in Android. You're usually not going to use that. There's a couple specific uses they have for it, but you can generally ignore that and always return 0. To read it back in, obviously we won't have a person object yet, so we need to use a static function to be able to recreate it. We do that by using a companion object in Kotlin. And the companion object, kind of similar to when you have static functions in Java. What we'll do is create this field creator, and by marking it JVM field, that makes it a static field in the Java version of this class. And he's going to implement parcelable creator, passing in the type that we have. And there's two functions in there, create from parcel and new array. So the create from parcel is the read side of what the write to parcel did. So the read side up here is going to read the things in order. So the read string, read int, similar to we had the write string and write int. And then create an instance of whatever object you were creating. So in this case, the person. New array is necessary because unfortunately there's no way to create a generic array in Java or Kotlin automatically. So it can't just take a look at the type of this person and say, oh, I'm going to create an array of person. It's just not possible to program that, unfortunately. So what they need to do is have you fill in this function. So you just actually create that array with whatever size you want and just initialize it however you need to. In this case, I'm initializing the entire thing to nulls so that it can be filled in later. This is used under the covers if you submit an array of objects. So if we send an array of persons across the pipe, it would use this new array on the other side to first of all create the array and then fill in the persons as it reads it. Now you notice that was a lot of boilerplate right there. Fortunately in Kotlin, there's a way to get rid of all that boilerplate. And you can use this parcelize annotation, which is in the Kotlin X parcelize package. And if you just throw that in front of your data class, that's all you need right there. In your build.gradle, you need to include the Kotlin parcelize plugin so that it can generate all that code that's necessary to do the read and the write of the parceled object. So now that we have a way to take our data and marshal it, let's talk about how we actually can communicate with a remote service. This is going to be a service that's running in a different process, so that means there's no direct shared memory. So all the data is going to be shuffled over a network connection between those two processes. So your data is converted to a binary form. That's the marshalling process. And anything that's a primitive, string, or character sequence is already supported. Those are the easy ones to start with. Everything else has to be a parcelable. Well, this is wonderful in this slide. I have the word primitive written there. And poof, it's gone. The wonders of pausing the video and editing the slide on the fly. So everything else must be parcelable so that you can send it across the pipe. Now, arrays of things or lists of things or maps of things or a bundle of things are supported if all the contents are supported. So the contents themselves have to be some kind of parcelable thing. One little note, if you're using an array or a list, you can use the generic form of it when you're specifying it in AIDL. But if you use a map, you're not allowed to. And I'm not quite sure what the reason is for that. There's probably something that's a little tricky to generate out of that. So they just pass a hash map of just object, or in Kotlin terms, any. But just keep in mind, you can't specify the generic types on a map when you're passing it. but you can actually pass maps. It's just you're not going to have the type safety of it. So there's two ways that you can actually send the data between the services. One is a messenger, and a messenger is a predefined object that has some fields you can just stick some data in. The main field that you're interested in is called what, and that's really the thing that's describing your protocol. So if you had a couple different functions, like let's say you had an add and remove function. Your add might have a what value of 1, your remove might have a what value of 2. So you're really defining your protocol based on just numbers. If the data being passed back and forth is just some simple ints, you can use arg1 and arg2. If the data is more complex, you can either use the obj field for the object field, which you can pass in a single primitive or parcelable object, or you can set data, which is a bundle that can contain whatever you need inside of it. Bundle is basically an Android version of a hash map that has the parcelization built into it. The other approach is to use AIDL. And this is a little bit more complex because you're actually defining your protocol as though you're defining classes. This is very similar to Corba or remote method invocation inside Java. This makes it feel like your remote service really is an object that's running inside the local process because you're just going to call functions with parameters. Now, all these parameters, again, they have to be primitive or parcelable. And you have the option of making them in, out, or in-out parameters. And what this means is an in parameter is only going to be marshaled as sending it to the service. An out parameter is not going to be marshaled when you send it, but it'll actually return the data and then update that object. So you have to make sure it's an object that can be updated. An in-out parameter gets marshaled both ways. So you have some data going up and you have some data coming back. So if we're looking at the messenger version of this, using a messenger to send it across the pipe, and you'll ask the messenger for a message that you can send. And that message contains the what and the arg1 and arg2 and so on. So you'll set that data, send it across the pipe, and then on the other end, the messenger there will interpret it and then call the service function for you. You'll have a callback that you've set up there to accept it. That callback is called a handler, and he's sitting inside the messenger. And this handler will retrieve the data and call whatever you want over here. And on the front end here, the handler will retrieve the response and do whatever you want with it. A better way to do things, or at least in my opinion, it's much more clear, is to use AIDL. This stands for the Android Interface Design Language. It's very similar to RMI in Java or Corba, and it'll generate your message passing code in two classes, a stub and a skeleton. The stub is your client side of things, the skeleton is your server side of things. Your AIDL looks something like this, and it's kind of Java-like. There's a few little things that don't quite track with Java, like, for example, the in and out parameters. They don't quite track with Java. And if you reference anything, you have to always import it, even if it's in the same package. That's one that tends to catch people. If you're referencing primitives, like int, you just reference them in the parameters. If you're referencing anything that is a non-primitive object that you're defining, you need to create an AIDL that represents it. So in this case, this AIDL for person just says I have a parcelable thing called person, and it's defined in com Java Dude service. That's the only thing we need in AIDL. Your actual definition has to be in the same package with the same name. So com Java Dude service, the class name is person, and it has to be parcelable. So in this case, we're just using the parcelize support in Kotlin to generate that. And boom, that'll transfer it across the pipe. So here's kind of what this looks like in a diagram. We're defining our service AIDL. It's generating these stub and the skeleton here. On the activity side, the stub looks like the API of the service. So it really just looks like an object you're talking to. You'll talk to that calling some function. It will marshal the data. That's what the stub's job is to take the parameters and marshal it, send it across to the skeleton, who will unmarshal it, and then call the actual function on the service side. If the service is going to return any data, it returns it back to the skeleton, who sends it back to the stub, unmarshals it, and returns it. So it really just looks like this service is sitting here in the same process, but it's not. Things get a little bit more complex when we want to do callbacks on this. So if we had a reporter function or something like that we wanted to take the reporter object and add the reporter to the service so it could call us back, we would define a service AIDL, and a callback AIDL. And again, these can be named anything you want. So this could be robot service and robot callback, or on robot changed or something like that. So your activity may call the add callback function, passing the callback stub across over to the service skeleton, who will then hold on to it. And when the service wants to make a call to a callback, he just uses that stub the same way we use the service stub. So as we come through here from service stub to service skeleton to service, the service goes from callback stub to callback skeleton to callback. So from both sides, it really looks like the objects they want to work with are right there for them. Now let's make this a little more concrete. Let's talk about a music player example we're going to do here. And this is one using a started service. So we're not using a bound service. This is a started service. And what we'd like to do here is in the user interface in our activity, we have our play, pause, and our stop button. And when you hit the play or pause or stop, we want it to start playing the music or pause the music or stop the music. However, if the user gets out of the activity while the music's playing, we want the music to keep playing. So the idea with this music player is that you can go in, start your song, go out, look at Google Maps, send an email, whatever, and your music's going to still keep playing in the background. To do this, we're going to create a service class here that's responsible for doing the playing of that music. And what we're going to do is when we hit any of these buttons, we're going to call start service to start this service up. And we're going to send an intent describing what button was hit. So is it play, pause, or stop? And that information will come to the onStart command function inside the service, who will then take a look at the data inside that intent and figure out what to do with it. He'll either play, pause, or stop the music. Now, because we want to try to make sure as best we can that this service keeps running and that the system doesn't kill it, we need to mark this as a foreground service. And one of the requirements of a foreground service is that you have a notification pop up in the user's notification bar to describe that the service is running and maybe why, maybe have some controls, things like that. So this notification is going to tell us the name of the song that's playing and have a play, pause, and stop button on it, so that if somebody hits those buttons, we can control things. However, this notification is not running in our application. So we need some way to send information to say, hey, the user is changing the state, the user is pressing play, the user is pressing pause, the user is pressing stop. So what we do is we set these buttons up to broadcast an intent. So we'll broadcast a play, broadcast a pause, broadcast a stop. And because we're using a broadcast, we can have any number of broadcast receivers that I'm representing by these little mailboxes. On the service side, this broadcast receiver is going to get that intent and then change the play, pause, or stop of the music. So he's actually going to do that. And then he's going to update the notification on the screen. The reason I'm doing that is because I'm changing which buttons are visible. If you're not currently playing, the only button you'll have available is the play button. If you're currently playing, you'll either have the pause or the stop buttons available. And if you're paused, you'll have the play or the stop buttons available. So the service needs to update that by calling that start foreground to update the notification. Now on the activity side, we're listening so that when we hear these buttons are pressed, we can just update our state and make sure that the buttons that are being shown are the right buttons. If the user has the notification shade pulled down, you might see the user interface change depending on the version of Android. Versions of Android prior to version 12 would have a fairly translucent version of the notification background. So you can still see part of your activity behind it. Android 12 doesn't, it's opaque. So while you're inside the notification shade, you hit a button. When you close the notification shade, you'll see the UI, and the UI will actually have the updated state shown on it. So this is a perfect use of a broadcast intent because we really want two things to respond to the same notification. We want to actually change the music playing or not, and we want to actually change which buttons are visible on this GUI. Now I've also set this up that if the user hits stop, I'm going to send this intent over and we're going to have the service stop itself. And what that does for us is make sure that the service isn't left around running if the user exits the activity. And similar with the buttons here, if that stop comes through this start service command, the onStart command, and we see it's a stop, we'll just go ahead and shut the service down because we'll consider that a notification to shut it down. So this is a really simplistic version of a music player, just to kind of show you the communication between the background service and the activity. Most music players are going to do something kind of similar to this. The way that I'm implementing it is a fairly straightforward, naive way of doing it. There are some really nice support for creating music clients or media clients in general. If you do a search for build a media browser service, you should be able to find that. And it describes in a lot more detail how you can set up a client for actually browsing media, playing media, things like that. I thought it was overkill for this application, and I really wanted to show how you can manage the communication between a service and a client. Then for an example for a bound service, so we're going to do a really simple kind of dumb application here. It's going to have a little GUI on the screen that has a progress bar that's going to show a count that's happening over inside the service. So when the service is running, he's just going to spin forever, updating this count and then sending it back over to the activity. The reset button is going to trigger that count to go back down to 0. We're also going to have the service send us an array of people. So in this case, I have Jenny and Tommy with some age numbers here, and these age numbers are going to go up as the count goes up as well. A very, very contrived application, but mainly what I'm trying to do is show some things you're going to need to do in the assignment. When you're sending your alien list back over to the client, it's going to be very similar to how these people are being sent. So this activity is going to start the service right away when it's running, and he's going to call add reporter as soon as he has a connection to the service, passing over a reporter stub so that the service can communicate back to us. Whenever the reset button is called, we're going to call reset. Now, both of these are going to marshal any data that's passed across, unmarshal it on the service skeleton side, and then actually talk to the service directly. When the service starts, he's going to kick off this coroutine to do the counting. Then whenever he wants to report it, he talks to that reporter, sending the information back across. The callback updates the user interface. So pretty simple process here. And for this example, we're going to be running this in the same application. However, for your assignment, I want you to create a separate project that you'll put your bound service in, and you're going to be talking to that. That'll make it feel a little bit more realistic that we're talking to another application. So in this case, for the assignment, this other application is responsible for monitoring aliens, and he's communicating with the website to get information about those aliens and then reporting them to any other application that's interested. To do that, we're providing a simple API that just sends this alien report back across to anybody who's registered. So keep in mind when doing your assignment, it's going to be very similar to this example. It's not going to be similar to the music example.